Welcome, everyone. We saw briefly what edge machine learning is in the introductory video. As we discussed there, edge computing is a concept where the data is processed closer to where it's being generated. If you are familiar with the concept of IoT or Internet of Things, you will find this definition to be eerily similar, and that is true. But there is one key difference between IoT and edge computing. With IoT, the core idea is to connect multiple devices to collect data and then send this data to a cloud provider or a central server somewhere where it could be processed and analytics could be performed. Edge computing, on the other hand, requires that both data collection and processing happens at the device for multiple reasons like high response speed and data bandwidth constraint, to name a few. We will look deeper into some of these reasons in the next video. Coming to the ML portion of the definition, there are lots of ways you can use machine learning on edge data, but the two most common use cases are sequence data and image or video data. Sequence data could be sequences of temperature readings, sequences of height readings, or sequences of accelerometer readings, and so on. Image and video data could be images or videos of animals, manufacturing products, cars, or any other object, really. Processing image data comes under the field of computer vision, and in this course, we will be focusing on computer vision due to the wide array of applications that it can be used to create. And so, to summarize, with Edge ML, you collect, process, and make predictions with data using machine learning, all at the edge. Neat, isn't it? Now that we have a better understanding of edge machine learning, let's also quickly look at a few definitions from the big technology companies. According to Edge Impulse, the platform we will be using in this course, edge machine learning is the process of running machine learning algorithms on computing devices at the periphery of a network to make decisions and predictions as close as possible to the originating source of data. It is also referred to as edge artificial intelligence, or edge AI. And so, a pretty straightforward definition, which points out that both collecting and processing of the data happens at the edge and using machine learning, just like we talked about. According to Red Hat, another technology firm, edge machine learning refers to the process of running machine learning or ML models on an edge device to collect, process, and recognize patterns within collections of raw data, to be collected and processed in real time, resulting in faster, more reliable analysis. Again, as you can see, an almost similar definition, but they also included a reason: the faster, more reliable, real-time analysis for doing edge ML. Finally, let's look at AWS's definition. According to AWS, machine learning at the edge is a concept that brings the capability of running ML models locally to edge devices. These ML models can then be invoked by the edge application. ML at the edge is important for many scenarios where raw data is collected from sources far from the cloud. Notice how AWS's definition has more practical elements to it and talks about both the distance between the device and the cloud and the use of an edge application to generate inferences from ML models. Hopefully, this gives you some flavor of what edge ML is. In the next video, we will look at some of the reasons for doing edge ML. See you there. Welcome to Why Edge Machine Learning. Now that we have a better understanding of what edge ML means, let's look at why we need edge ML. As we saw in the Red Hat definition, the primary reason for edge ML is low latency or real-time prediction requirement. Let's take the self-driving vehicle example again and see why it is super important that self-driving cars use edge ML. Let's say there's a self-driving car driving itself on a busy city road. As it drives, it collects data about the weather, the time of the day, pedestrians, cyclists, other cars, the road signs, etc. It uses this data to make decisions about whether to accelerate, brake, turn left or right 30 to 50 times per second. If this data was to go to a cloud provider or a central server, it would be impossible to get the decision back to the car in this time span of 0.02 to 0.03 seconds. Think of the consequences in that case. Another reason for using edge ML is poor or no connectivity to the cloud. Extending the self-driving car example, let's say you wanted to go on a hiking trip to a mountain, or maybe on a desert safari in your self-driving car. If these remote places had bad or no internet connectivity, the self-driving car wouldn't work. Taking another example, let's say you are in charge of maintenance of an oil and gas pipeline that goes through 1,000 kilometers of desert. Manual inspection in this scenario would be impractical. Using a regular IoT device and sending pipeline pressure data to a cloud provider or a server would also not be possible due to connectivity issues. The solution? Again, use EdgeML to perform data processing at the edge and then send a radio signal to the nearby transmitter tower, which can then transmit it forward to the concerned authority. The third reason for using EdgeML is the high bandwidth and cloud provider cost. Coming back to the self-driving car example, let's say for the car to work, it in each cycle produces 6 images, some LiDAR data and some proximity sensor data totaling 5 megabytes. As we discussed previously, decision to accelerate, brake, turn left or right is made on this data. This decision is made 30 to 50 times per second. So in 1 second, at least 150 megabytes of data is generated. For a half an hour ride to the office and back, 22 days of the month, 11.3 terabytes of data would be generated. So not only would your internet cost be extremely high, but also your cloud provider cost. Something similar would happen with the cost if you were to take images of products on a manufacturing conveyor line and then send them to the cloud to make a decision as to whether the product was defective or okay. The solution? Use EdgeML to make product quality decisions locally at the edge, as shown, to substantially reduce your ML running or operating costs. The final reason you would want to use EdgeML is the legal restrictions and compliance requirements imposed on and by certain industries. Let's say that there is a government facility and it uses cameras to monitor the 24/7 security of the place, both inside and outside the building. If we were to send this video feed to the cloud, there is a chance it could be hacked. We have all seen movies where bad guys hijack the video feed of important government establishments, and as the in charge of security, we wouldn't want it to happen to our place. So, what do? Of course, EdgeML. Hope you enjoyed this video, and I will see you in the next one where we talk about computer vision. See you there. In the last few videos, we have used the word computer vision a couple of times. So let's explore computer vision a little bit now. Stated simply, computer vision is a field where you use machine learning and artificial intelligence to process images and videos. This is slightly different from image processing, which uses non-machine learning algorithms to process images and videos. However, a lot of people use the two interchangeably, so look out for that. Like before, let's look at a few definitions of computer vision from the big technology firms. Microsoft defines computer vision as a field of computer science that focuses on enabling computers to identify and understand objects and people in images and videos. Pretty simple and straightforward, right? Let's now look at IBM's definition. IBM defines computer vision as a field of artificial intelligence that enables computers and systems to derive meaningful information from digital images, videos, and other visual inputs, and take actions or make recommendations based on that information. As you can see, IBM's definition is a little bit more in-depth, but again, pretty straightforward. And here's what the big industry players are saying about computer vision. According to a McKinsey survey, computer vision is the second biggest AI capability embedded in products and processes, and personally, I think it is going to get even bigger in the next 3 to 5 years. According to IBM research, computer vision market was valued at a staggering $48.6 billion in 2022, according to estimates. And again, this is just the computer vision market and not the total value of products and services that deploy computer vision. Forbes gives us a number for that. According to Forbes, computer vision and vision data will help enable Industry 4.0, which will create value of $1.2 to $3.7 trillion by 2025. That is bigger than the country with the 5th largest GDP in the world, according to World Bank's 2023 estimates. And there you have it. That was a quick summary of computer vision and its future outlook as projected by industry insiders. In the next video, we will look at some of the applications of Edge AI using computer vision. See you there. Welcome back. Now that we have a better understanding of what Edge AI and computer vision are, let's look at some of their applications. One of the biggest applications of Edge AI is in autonomous systems and robotics. And this is one area that I believe will just explode in the next 5 to 10 years. An autonomous system is any system that makes decisions on its own without any human intervention. Combine that with robotics, and what you have is wheeled robots, humanoids, self-driving cars, trucks and other vehicles on land, autonomous underwater vehicles or AUVs in water, and unmanned aerial vehicles or UAVs or drones in the air. Let's look at a few details on how autonomous robotic systems use Edge AI, or machine learning and AI in general. An autonomous system has multiple software components. One of the components, called the perception stack, is the one that uses computer vision to detect different type of objects. For a self-driving car or a delivery robot, it detects static objects like traffic lights, road signs, traffic cones, and other road obstructions. It also detects and tracks dynamic objects on the road like cars, cyclists, pedestrians, pet animals, etc. Finally, it detects drivable surface and lane boundaries, and that's what keeps these self-driving vehicles on the road and delivery robots on the footpaths. While most of these are done using data captured from multiple vision sensors or cameras, in some of the systems, other sensors like LiDARs and ultrasonics are also used. It is a fascinating area of research and one of the core systems for autonomous robotics, and I would highly recommend you spend some time on this if you have an interest in robotic systems. Another component of a robotic system that uses machine learning is the control and the planning stack. Most modern planning stacks use some variation of deep reinforcement learning to make short-term decisions, like when to accelerate, brake, turn left or right. And that is all for this video on Edge AI's application to autonomous systems. In the next video, we will look at how it can be applied to the transportation and the urban planning domain. See you there. Welcome back to another video on Edge AI applications. If you're just starting out, these and some of the applications in the next few videos are slightly easier to develop as compared to robotics, but equally impressive and a good starting point for your entrepreneurial journey. In this video, we will be looking at Edge AI applications in transportation and urban planning. The first one is parking space occupancy detection. Let's say you go to the market for some shopping, but the nearby parking space is full. What do? Well, you take your phone and check out the Parking Space Finder app for the nearest available parking. The app shows the parking rate, the distance from your present location, as well as the number of slots available. And that is it. You find a spot you like, book it, and go there and park. Under the hood, the app uses cameras installed at different parking locations and Edge AI to identify the vacant spots and sends that information to a cloud database. The mobile app then fetches this data from the database in real time or near real time and shows it to the user searching for parking spots. Some other applications that work in a similar way are traffic flow analysis, traffic violation detection, vehicle identification for toll collection, road condition monitoring, and driver distraction detection. With traffic violation detection, cameras at different locations in the city can detect whether you did a traffic light violation, were overspeeding, or stopped after the stoppage line, etc. These images, along with the prediction, can then be sent to a cloud provider from where an automated ticket can be generated and sent to your home. For traffic flow analysis, data can be collected from cars' GPS and from cameras installed at red lights and important junctions to assess congestion. This can then be used along with historic data and government data about weather, road conditions, and repair work, etc., to regulate red light stoppage time, as well as inform other drivers moving this way. For vehicle toll collection, you no longer need to stop and pay every time. You just need to slow down. A camera can then detect and read the number plate using Edge AI and then charge the toll to your card. To reduce mistakes in toll charging, a verification step can also be added that confirms your car's location using GPS data. For road condition monitoring, an Edge AI-enabled camera inside the car can be pointed at the road. In case the road conditions are bad, an image along with GPS data can be sent to the Department of Transportation, who can collect and analyze the data, and then decide where to rebuild the road depending upon the number of complaints, budget constraints, and other criteria. Similarly, for driver distraction detection, The Edge AI-enabled camera can be pointed inwards towards the driver. If he or she yawns, is talking on the phone, or in general, distracted, a message can be sent to the driver's family member. I hope you enjoyed this video and are starting to correlate these with some of the things that you see around you. In the next video, we will look at Edge AI applications to sustainability and farming. See you there. Welcome back. In this video, we will look at Edge AI's application to sustainability, agriculture, and aquaculture. Imagine you are a wildlife conservation and safari firm. You want to track wildlife movement across the jungle so as to give safari tourists a good view and thus a good time. With the money and the data generated, eating and migratory patterns of different species could be studied, and specific wildlife conservation programs could then be designed and implemented. To achieve this, you could set up Edge AI-enabled devices at multiple locations in the forest. The cameras would take an image every few seconds, make predictions, and in case an animal was detected, send a message to the safari jeep driver. If the part of the forest had good mobile service connection, a GSM or GPRS module could be attached to the Edge device for sending across the messages. If there was little or no cell service, the concept of radio signals that we discussed previously could be used. Edge AI can also be used in agriculture. Some Edge AI applications to agriculture are crop yield monitoring, weed and pest detection, plant disease detection, and irrigation management and harvesting. Let's say that you have a tomato farm and you want to automate some of the tasks using Edge AI. One way you could do that could be by laying tracks between the plant aisles. A robot with camera could be installed to run on these tracks. The robot would take images of the tomato plants every 25 to 50 centimeters and then use computer vision to determine the presence of weed, pest, and disease in the plants. It would also check and see if any of the tomatoes were ready for harvesting. These predictions could then be sent to the farmer along with the robot location so that he or she could perform the necessary action. This Edge AI application would improve productivity and reduce farming costs substantially. An advanced version of this application could be to install a robotic arm that would do weeding, spray pesticides, and harvest the ripe tomatoes autonomously without human intervention. An alternative to the above solution could be to use a GPS-enabled drone with a camera instead of the robot. This would make practical sense if the area to scan was large. The drone could also be used for irrigation management by taking images of the soil to determine their need for water. An irrigation management system could then open the valve and release water at the exact location where the drone found the soil to be dry. Similar solutions could also be developed for livestock farming, where a robot could refill feed and water trays for cows, pigs, goats, hens, etc. For animals that graze in the open, like cows and sheep, drones could be used to track the animals to ensure that no one was left behind. Let's discuss aquaculture now. Aquaculture is one domain which has seen a lot of Edge AI applications in recent times. Like some of the examples discussed in this video, aquaculture firms use Edge AI-enabled cameras to track and count the number of fish, for feeding, to check for disease, and for assessing the time to harvest. And that is all for this video. In the next video, we will look at the application of Edge AI to manufacturing and retail. See you there. Hello and welcome, everyone. In this video, we will talk about how Edge AI can be applied to manufacturing and retail. Some of the applications of Edge AI to manufacturing are defect detection, personal protective equipment, or PPE detection, and productivity analysis. Detecting defects in manufactured products is usually handled by the quality control department of an organization. While new methods using lasers have been devised, checking the quality or the presence of defects in products is still largely a manual job that is time-consuming and costly. Edge AI-enabled cameras can do this in a fraction of the time and money by taking images of the product from multiple angles depending upon the complexity of the product shape, and then making a prediction whether the particular product dimension was within tolerance limits or outside. These predictions, as can be seen, would then be sent to a higher-order Edge AI device, which would collate them and make a final prediction on the status of the product. Safety at work is another area where Edge AI can be applied. Most organizations, especially manufacturing, construction, and retail, spend a lot of time and energy ensuring that the workplaces are safe for their employees and that the employees are taking proper precautions and following procedures for their own and their colleagues' safety. Edge AI can support this through Edge AI-enabled cameras, which can process the video feed of shop floors in real time and send notifications to the concerned department if it finds that an employee is not wearing protective equipment like masks, vests, safety helmets, safety boots, etc. Another area where Edge AI can be applied is productivity analysis. Productivity analysis, as the name suggests, is done to improve the productivity on the shop floor and to minimize wastages. These cost savings, which can be substantial, can then be passed on to the final consumer to make the product more competitive. Productivity analysis of a manufacturing or a retail shop floor using techniques like Lean Six Sigma, Maynard Operation Sequence Technique, or MOST, and Value Stream Mapping, or VSM, can take anywhere from a couple of months to a year. Analyzing the video feed using machine learning and collecting data on product, people, and processes can help lean consultants do their job in a fraction of the time. Along similar lines, on a retail floor, Edge AI can help the product stocking guy understand the flow of products from shelves. He can then use this data to change processes, like reducing the time to check on an aisle from 2 hours to 1 hour, or stocking some of the products nearby in cartons to reduce the replenishment time for fast-moving products. Finally, Edge AI can also help redesign supermarkets and retail stores. This idea is currently a hot favorite of many of the top retailers in the US, UK, and Europe. The idea is to use video feed from the stores and use machine learning to analyze the number of people entering the store every hour, their shopping path, the time they spent in each aisle, the time they spent at the checkout counter, etc. This data is then used to make daily operations smoother by putting more staff on the floor during peak times, widening the aisles with more traffic, modifying replenishment strategies like we discussed before, and adding or reducing the number of active checkout counters, etc. I hope you enjoyed some of the ideas that we shared in this video and will use them to develop unique ideas for your own startup. In the next video, we will look at application of Edge AI to sports. See you there! Welcome to this final video on Edge AI applications. In this video, we will look at ways in which Edge AI can be used in sports. One of the first use cases is athlete training and performance assessment. Whether it be football, cricket, tennis, baseball, or any other sport, video feed of an athlete can be analyzed for pose estimation and motion analysis using machine learning to find out if the player is putting undue stress on his or her body and is in the danger of being injured. The player can then be retrained so as to reduce the probability of this happening and ultimately increase his or her career span. This pose estimation from video feed can also be used to find ways for the player to improve his or her technique and to generate more power in their throws and their shots. Another use case of Edge AI can be in the generation of real-time analytics. Assume you are a sports channel and your audience would like to see some statistics on how the teams and players are performing. For football, this could be the number of fouls, the number of free kicks, the number of corners, etc. For cricket, this could be number of no balls, wides, catches dropped, etc. For tennis, this could be the number of aces, the number of foot faults, the number of times the ball hit the net, and so on. What you could do in this scenario is to split the video feed into 1 to 3 second clips and then run event detection video analytics on them to generate the metrics. Note that while this can also be done by streaming video data to the cloud and then performing the analytics there, the application of Edge AI is a far more efficient way, in our opinion, if you can set your own camera systems at the stadium. One final application to discuss is the automated refereeing and scoring system. Sports are a big part of our lives now, and an incorrect referee or umpire decision can not only break the hearts of millions of fans, but also have a big impact on the careers of teams and players. One way to reduce errors is to use Edge AI. Cameras placed strategically can look at the short video clip and make predictions on the play. For football, this could be prediction of a free kick, yellow card, or a red card. For cricket, this could be LBWs and edges to the keeper. For tennis, this could be whether the ball was inside or outside the line. In fact, we believe this system has already been put in place at a couple of tennis tournaments. Lots of opportunities, however, still exist to make this system better and to implement it in local, school, and college-level competitions for a wide variety of sports. And that is all for this section. This section covered just a few of many Edge AI applications possible. If you are interested, I will add a few links to blog articles from V7 Labs and Viso, two firms who, along with Edge Impulse, are doing some great work in this domain. Do check them out to get more ideas on how Edge AI can be used in real-world applications. In the next section, we will look a little deeper into the hardware side of Edge AI, which is the Edge device, and understand its working, as well as explore the different input and output devices that can be attached to it. So, see you there!